Welcome you all to the Research Spark YouTube channel. Currently, we are talking about the course Analog and the Linear Electronic Circuits. Now, this is the first session of the Unit 2nd Introduction to the Linear ICs. So here is the syllabus for the Unit 2nd. So it contains basically the two things, that is the BJT and MOSFET based differential amplifier and the application, that is the operational amplifier. So we'll talk about it. So in this session, we are going to talk about the BJT differential amplifier with passive and active loads, MOSFET based differential amplifier with the passive and active loads, and we'll also look into the some internal structure of the operational amplifier. So let us start from the basic of the differential amplifier. First, differential amplifier simply what does it mean? So if we are giving the two different inputs, then definitely the difference of that inputs, that is the signals, can be amplified and with a huge amount. So this is the basic purpose to design the differential amplifier. So ideally it can have the two different types of the inputs. First, either it may have the different inputs, that is the differential mode input, or either it may have the same input, that is the common type of the common mode input voltage. So how can we define? So you can check here, the gain can also be calculated. V out will be equal to the gain of your differential amplifier into the difference of the voltage, that is V1 minus V2. Uh, Similarly, we can also define the differential mode input voltage, that is VD. VD will be the represented always as the difference of the two different input voltage that we wanted to amplify. And VCM, VD, both are the input signals, input voltage only. The difference is only the VD is representing the differential mode input and VCM is representing the common mode input. Means common mode means the both the inputs will be the common. And V out is representing the output, amplified output voltage. That is the gain into the input voltage. Okay, so how will it works? So here just check that this is the BJT differential amplifier. So if you remember, it contains the two different BJT transistors and the emitters are connected together with their emitter terminal, and the collector terminals is connected with the VCC, that is the V plus, and the emitter is connected with V minus. So the advantage to connect your emitter terminal with V minus is to not require your voltage divider circuits and the capacitors, no need to use, because you already have applied the instead of the ground we have applied the V minus. Now, so input voltage you can supply through the VCM, that is if it is the common mode, or you can give the difference. So here VCM you can give through the base terminal only. So if both the base are having the same input, that is VCM, so first structure is representing the common mode. Independently also you can give the voltage, same voltage to the both the base. Always remember, we will give the AC input voltage always through the base terminal, and here we are going to collect our output voltage through the collector points. And second one as structure is showing the only one difference is that now we are going to give the differential mode input voltage, that is the the signals whatever we are giving that are the different across the both different terminals. Output again we are going to collect through the collector terminals. Here if you will check the DC analysis, then simply you can make a the DC analysis using the KVL or KCL. So V plus is there, that is VCC, and the current which is flowing through the RC circuit, that may be the IC or IQ by IQ, and if you will add both the IC circuits, then it will equal to the emitter current. Means you can write 2IC is equal to the IA, and also the IB will be very small, means it may be nearly to the microamperes, so you may neglect. So now DC transfer characteristics. So how will you calculate? Again, you just perform the DC analysis with the help of the same circuit analysis. You can write VCC minus ICRC and you can find out the VC1. Similarly, in the right loop, you can write V plus minus ICRC and equal to your VC2. And if you wanted to move through the base terminal, then zero base voltage VBE and your IRE is like the IQ, that will be equal. So in that manner you can find out the AD, that is the differential mode gain. So that will be V out by VD, that is the input voltage, which will be equal to the GMRC or IQ RC divided by twice of VT. VT is your threshold voltage. Now, how will you draw the small signal equivalent circuit? So right side is showing the small signal equivalent circuit for the same analysis, same circuits. So I hope you remember how to draw the small signal equivalent circuit. So you can replace the transistor with your GMV pi along with the resistor, that is the R pi, and the rest of things are same. Now again you have to find out the V out and V in, and you can find out the AD and ACM. After finding the AD and ACM, you can find the CMRR, that is the common mode rejection ratio. So remember, while you are finding the AD is the gain while you are putting the differential mode. So the the it depends on the value, the inputs whatever you are giving, so nothing is different. ACM, that is you are you wanted to find out the gain, that is the amplification, if you are giving the same input across the two different base terminals. CMRR will simply calculate the ratio of the gain which you have calculated during the differential mode and the common mode, that will be simply, which can be calculated with this formula equal to half of 1 plus 1 plus beta into IR divided by VT into beta. So now let's talk about the differential amplifier with active load. So just check the circuits here. It contains the active load. Here means the some more transistors are here. We are connecting the board transistor. So like if we are having the active load, in that case you can connect some this is the example of the 3 transistor active load, and the second again stage. So you can check there. This will help you to get the better matching. So also right side is showing the small signal, that is the small signal equivalent circuits is for AC analysis. You can draw the equivalent circuit and find out the gain for the differential mode, and also you can find out the gain for the common mode. So check here, the formulas are there. AD is equal to your V out by VD is equal to RM R naught 2 parallel with R naught 4 parallel with RL. RL is the your load resistance. R naught 2 is the your output resistance of the transistor 2. R naught 4 is the output resistance of the transistor 4 simply. Now coming to the FET differential amplifier. So this is the basic MOSFET differential pair configuration. It contains, this one is the very similar to the BJT based differential amplifier, if you check. So here two MOSFETs are there, and again we are going to give the inputs through the gate terminal and we will collect the output across the drain terminal. So with the help of the small signal equivalent, and that is the AC equivalent circuit, you can find out the gain that will be equal to the AD. Again, this is the gain of the differential mode, which will be equal to GMRD divided by 2, or you can also write K and IQ divided by 2 into RD. So if you wanted to calculate, just do the DC analysis, very simple to find out. As you know, if you remember, ID is equal to of mu cox WIN VGS minus VT into VDS. So with the help of that only you can find out. Now a small signal equivalent circuit for the MOSFET differential amplifier is here, and how will you replace? So simply replace your MOSFET with the VGM into VGS, that is of the current source, and the open gate means the gate will be the open because of the very high resistance in between the gate and the channel. RD will be as usual, and then find out the AD and ACM and the CMRR, which will be equal to the half of 1 plus 2 square root of 2k and IQ into R naught. So if you wanted to derive this, how to find out this CMRR, you can check the Nilman book as well. It may take some long time, but if you drop the comments, I may derive it. MOSFET, a differential amplifier with active load. So here again we are going to connect some more MOSFET based transistor in order to make it the active load. So towards the load we are going to connect some more MOSFETs. Again, just redraw the AC equivalent circuit and find out the gain, which will be equal to the V out by VD, that will be equal to the GM R02 parallel to R04. Okay, so major thing is that why are we studying the differential amplifier? What is its application? So the major application is your operational amplifier. So check this circuit. This is nothing, only the differential amplifier based. So here is the block diagram. What are the things are containing your operational amplifier? So first thing is your symbol. Symbol contains the V plus, V minus. These are the different inputs. That is your V1, V2, and the V out is your, the output terminal only. Vs and Vs minus. This is your V plus and V minus. Means your signals, the power supply, DC power supply that we wanted to supply across the differential amplifier. So primarily your operational amplifier will contains the three states. First is your differential amplifier only. Second is your gain stage. Third is your output stage. So the differential amplifier is the most important stage of this operational amplifier. Check the right side circuit, which is absolutely based on your differential amplifier only, and this is the basic design structure of your operational amplifier. And based on only this, there is IC that is called IC741, that is of operational amplifier IC only. So it contains this type of circuits. So if you will check carefully, you can find that it is nothing, only containing the differential amplifier and then your gain stage and the output stage. So this one is the really the transistors, that is the how you can design your operational amplifier. This is the real view of your operational amplifier, while we are going to use the symbol usually with the triangle formats. So that's all in this session. We'll look into the some more details of the operational amplifier in the next session. So in the next session, we will focus on the power amplifier class A and class AB push-pull complementary amplifier configuration. And after that, in the next class, we will talk about the some more characteristic of the operational amplifier. Thank you to all to listening me. If you have any problem, please drop your comment. Thank you.